Hello and welcome to Tiny Code Christmas Day 10, the big squeeze. Today's video is going to be divided into two parts. The first will be how we can combine multiple effects into our programs, and the second will be a discussion on compression. So until now we've been using the number of characters as a metric in our productions, but now we're going to also take a look at file size, and that has a slightly different approach to it. So the first section, I'm just going to show the code in TIC80. It's going to be the exact same for Pico 8, but I'm just going to use TIC80 because it's more readable. And then we're going to move on to a discussion on the compression that will cover both platforms and will offer general tips as well as platform specific ones. So we're going to start off with a look at how we can incorporate multiple effects into one program. So up until now we haven't really taken a look at the if statement in TIC80 or Pico 8, and we haven't really had to use it or make any decisions in our programs. So just in case you're not that familiar with it, I'm just going to show you here a basic if statement and how we can use that to set up different sections of our effects so that one effect will play for a few seconds and then it will switch to another effect. So this is a fairly basic way of doing this. There are much more complicated ways that you can do to incorporate multiple effects, but sometimes this is all you need. So before we go any further, I'm just going to explain the setup. I'm clearing the screen, I am putting the time into a variable t, and I'm printing it out to the screen. And when we run this, we'll see that it's printing out the number of milliseconds to the screen. So just be aware that the time that we're dealing with is in milliseconds. And if you're on an older version of TIC80 in particular, on certain platforms, Mac and Linux, the timing can be off. So just make sure you're using the latest version. So I'm going to put in an if statement here, and I'm going to say if t is greater than 2000, then an end. So this is an if statement, and it has if, then it has a condition, then it has the keyword then, and it will operate the code that I put in here conditionally. So this will only run if t is greater than 2000. So for now I'm just going to set up a basic effect, and I'm going to go CLS2. So our default color, when we start it, it runs CLS, and then if t is greater than 2000, so after 2 seconds, this should turn to red. And as soon as that hit 2, we see that that changes to red. So you see up here we have CLS as well, which isn't ideal. We have CLS here as well, but we're calling clear screen up here, and then we're calling it again down here if t is greater than 2000. So that's not optimal. So what I can do with an if statement is I can add an else. So this splits the if statement into two. And if this evaluates to true, if t is greater than 2000, then clear screen 2, else, or otherwise, clear screen. So now, is it 2? No. And now it is. It checks this first. Is t greater than 2000? It's not. Okay, so run clear screen. T keeps going. Eventually, after 2 seconds, t is greater than 2000. So CLS will be called with 2. And that's it for the rest of our program. Now, as it's running, it is going to stay red for the rest of eternity, and we can take a look at that in a second, but I'm just going to add maybe one more color to this, and if t is greater than 4000, then, and when we want to link 3 conditions, so I've greater than 4000 and I've greater than 2000 and then I've else end, we have to link these up, and we do that by using the else if keyword. So in this case I'll clear screen to 3. So this says if t is greater than 4000, then clear the screen to color 3, and then if that isn't true, it comes down here to the else if, and it checks to see is t greater than 2000, and if that is not, then it goes down here to else. It doesn't check a condition for else. Else is the default when all of the other conditions have failed, and it just clears the screen. So if t is greater than 4000, it calls CLS3, and skips the rest of the code. If that is false, if it's not greater than 4000 but it is greater than 2000, then CLS2 will be called, and then the rest of the code will be skipped. So we can see here that it allows us to set up our program in different ways with different colors at different times. And again, this is still going to be now at that color, clear screen 3, for the rest of the program, because t is greater than 4000. So one of the things that we can do to make our program wrap around, since we're using time itself up here, we could mod time by, let's say, 6000. So what happens here is time can be modded by 6000, and again that's the remainder after division, so we can modulo 6000, and that means that it will start at 0, and when we mod it by 6000, then it means that it'll go back to 0. So once it goes to 6000, it'll be back to 0, and that means that it will go CLS, CLS2, CLS3, which is greater than 4000, and then it'll get to 6000 and it'll wrap around again. So take a look up the number in the top left hand corner, and you can see around 2, 4, and as soon as it gets to 5999. It immediately increments, gets modded by 6000, and we're back to the start. So this allows us to set up multiple parts in our effect, and it's fairly straightforward. You can modify this setup, and anytime you need to add an extra part, you can just copy this, else if t is greater than 2000, then clear the screen. So I'm going to reduce this back to 2, and what I'm going to do is I'm going to bring in some pre-made effects. So now I'm going to change these out for actual effects, and I'm going to bring up some ones that I made earlier. So I'll pop a tunnel in here, and I will pop a plasma in here instead of the clear screen. So these are, again, the challenges from the previous days, and you can see that I have a t value here, and I'm assuming that they are using the base time value and they're taking care of it here themselves. That's a decision that you'll have to tune the effect based on the time as well. So let's just take a look and see how this works. So we have a plasma, and at 4 it should change to a tunnel, and at 6 back to a plasma. So I'm going to change this to 10,000 and 5,000. So we should have 5 seconds at our plasma effect, we should have 5 seconds with our tunnel effect, and then when that reaches 10 we should be back to our plasma, and so on forever and ever. So I'm just going to get rid of this code down here so that we can get a proper idea of the size of this. So we're at 333 characters. So how would we get this down to 256, especially assuming we might have already size coded this a bit? And one thing that we could do is, instead of having the if statements outside of the effects, we could rewrite the effects so that there was only maybe one set of for loops. So rewrite these so that they were both 0 to 135, 0 to 239, or minus 68 to 68, etc. And then in here you could have an if statement that decided whether you did this one or that one, and you might even be able to reuse the pick statement outside of the if statement, and that would save you a good bit of code. So it's up to you how you want to design and architect your overall program when you're mixing these two types of effects. And I just want to point out that while this is 333 characters, This effect will definitely be below 256 bytes when we talk about file size and compression, which is what we're going to move on to next. And so now we're going to talk about compression and specifically the file size of our effects. So this is something a bit different to what we've been doing so far. Both TIC80 and Pico8 have cartridge formats which have compression built into them. So we're going to talk about some techniques that will work specifically with that compression, and we'll also take a look at some general demo scene rules around file sizes. So the most important thing when you're going to enter a demo scene competition is to check the rules. For example, if you're entering a competition that has a file size requirement, for example a 256 byte fantasy console competition, you'll want to be aware of the rules. We've been working with text until now, but for these competitions you'll have to submit the cart. If you take a look at the carts you've been saving on Pico8 or TIC80, you'll notice that they're a lot bigger than the 256 bytes of text that's stored in the cart. And this in and of itself presents a bit of a problem because these platforms, TIC80 and Pico8, were adopted for size coding as opposed to being created for size coding. So we have to do a little bit of working around these. So if you're entering any competition, make sure you check the rules of the competition for size restrictions and any exceptions that there may be. So for example, some competitions allow you to exclude the header from small size limit competitions. So for example, in a 64 byte TIC80 competition, I may be able to exclude the 4 byte file header, meaning that I technically have 68 bytes of a file size to play with. So since we're talking about demo scene competitions, just a little bit of demo scene terminology for a second. So what is a demo? And a demo is basically what you've been making. It's an audiovisual program that demonstrates the technical ability of the people making it, the artistic ability, the musical ability, all packaged into one thing. It could be just code, or it may be a combination of these things I mentioned. So what's a production? A production is essentially the product that you're making. So when we talk about demo scene prods or productions, it's your code, it's your demo. So what's an intro? You'll often see a distinction between a demo competition and an intro competition. And a general rule of thumb is that an intro competition is size restricted. This could be something like 64 bytes, or it could even be something substantially larger, but still called an intro. This stems from the days of software piracy, when everything was put on discs and there would be so little space left on the disc, but somehow the people distributing the pirate copies would have enough room to put some kind of an intro. And these intros would have graphics, music, greets, sign scrollers, all of those things. So even now, we're still making things called intros because they have a size restriction, but they're not actually an intro to anything. So let's talk about the Pico8 first. Exporting a code-only compressed file is possible since Pico8 version 0.2.4.c, and that came out in April 2022. So if you haven't updated your version of Pico8, now would be a good time. This functionality is not available on the online educational version. If you try and do export, it'll tell you that functionality isn't available. You can export your code using the T switch from the command line. So export -T and then the name of your Pico8 ROM, and this saves only the code compressed as small as possible. And you can view the compressed bytes since August 22 by control clicking on the compressed code capacity status bar down at the bottom of your Pico8, and you can also use the info from the command line. So Pico8 uses a custom PXA compression format, and it does not transform the code. It leaves your code as is and just tries to find areas that are repeated in the code and replaces the repeated code with a reference back to the first point where it appears. There's an excellent application called PXA Viz, which allows you to visualize the compression on your Pico8 programs, and there's a link to that in the description. A lot of the character-based size coding techniques are still valid in Pico8 because the code isn't transformed or minimized by the ROM. Aliasing function calls, for example, may not be beneficial anymore because the first time one of those long function calls appears, it may just be a reference back to the first point. So essentially, you're trying to do the PXA compression algorithm's job for it. Another thing to make sure that you do, since this is based on commonalities, is to rewrite any similar expressions. So if you have something like a sine or a cosine, make sure that the terms are as similar as possible for as many characters as possible, so that you can take the entire first half of that equation and it'll be referenced then from the second one. So now we'll take a look at TIC80. and TIC80 requires some external tooling to reduce our file size to a minimum. The way TIC80 works is that it has different chunks. It has code chunk, a chunk that has sprites, music, and even if we don't use those things in our TIC80, they still exist in the cart. There are tools called packers that are available, and there's a few of them. The one that I'm going to recommend that you try first is Packetic or Pocketic. I believe one of them is the correct Finnish pronunciation, and the second one then is Pactic, and we also have TICTool. And Packetic is the most up-to-date of these packers. So what do these packers actually do? So they remove the unused chunks, sprites, music, etc., and they remove white space, and they actually transform the code as well. So this is a one-way operation. You run the packer, it takes your code, removes the white space, does tricks like the tick equal load and other stuff like that, and it'll basically do all of those little tricks that we've been doing for ourselves for the last while, and in some cases it will do them a lot better than us. So Packetic, for example, will also use genetic algorithms to try and figure out which variable names are better and which arrangement of an expression will compress better. These packers also compress code using better algorithms. So the algorithms that are used by TIC80 are fairly standard. It's essentially the same as those used in a zip file, but you can put a lot of time into the compression so that it comes up with a better heuristic and will result in a smaller file size. These packers also allow us to write reasonably readable code and not have to worry about minimizing the Lua ourselves. Packetic is probably the easiest of these to install. It requires Python 3.9 or greater and can be installed through pip. If you have Python installed, you should have pip installed, and from the command line on your system, be it Windows, Linux or Mac, you should be able to type pip install Packetic, or depending on how your system is set up, you might have to use pip3 install Packetic. Once installed through pip, you should be able to run Packetic from your system command line as follows, and again, that's just the location to where your cart is. And you can find out where your TIC80 carts are stored by typing folder into the TIC80 command line. So there's a lot of command lines going on here. The stuff to do with Packetic specifically will be on your system command line, and the folder to tell you where the carts are stored will go on the TIC80 command line, and it will also open that folder on your operating system for you to see. As a bonus, TIC80 uses the deflate algorithm to compress its code. Deflate is a combination of two different algorithms, LZ77 and then Huffman. So LZ77 finds segments of repeating code and replaces them with references to the original. This is generally over a certain number of bytes. For example, LZ77 has this concept of a sliding window, and that doesn't really matter when we're dealing with size coding because all of our code is small enough to fit within that window when it's searching for repetitions. And instead of using 8 bytes per character, Huffman coding will assign less bits to more popular characters, and then less used characters get more bits assigned to them. So the more you use a certain letter, the shorter the bit sequence becomes to represent it. So what does this mean? It means that things like aliasing, s equals mat.sign are no longer necessary if you're using a packer. It means that we have to rewrite similar expressions so that the terms are similar for as many characters as possible. And you can give Pactic a hint, and it can rearrange things based on some guidance that you give it as well, as to perhaps the order of operations. And one thing that you can do is you can try and avoid introducing single-use characters. So for example, 2 times 2 might be better than 2 to the power of 2 if you've already used the multiplication sign before. It's worth reading the documentation for Packetic, as that will give you an overview of the different types of transformation that it does. It does a huge amount, and it's a really nice piece of software. The last bit of advice is to pack early and often so that you can get an idea of how your effect is progressing and how the changes that you make affect the file size. That's it for today. Don't forget to come back and check out tomorrow's challenge.